Okay, so today's notes we are going to be dealing with angle relationships, aka special pairs of angles. Some pairs of angles are special because of how they are positioned next to each other. Now, the first thing I want to look at is adjacent angles. Adjacent angles are two angles that lie in the same plane and have a common vertex and a common side, but no common interior points, aka no common inside points. Now, before I look at these two examples of adjacent angles, let me go ahead and remind you how an angle is formed. So, remember, if you have two rays, here's one ray. It has an endpoint and extends in one direction. And then there's another ray. I'm going to use a different color. So it has to have an endpoint and extend in one direction. These two rays here, so the one in red and the one in blue, they share a common endpoint. This is what we call the vertex. Now that we know how an angle is formed, let's take a look at some examples of adjacent angles. Remember, adjacent angles are two angles that lie in the same plane and have a common vertex and a common side, but no common interior points. So, angle 1 and angle 2 are adjacent angles. This is angle 1, and this is angle 2. We can see that angle 1 and angle 2 share this common point here. That's our endpoint. That's our vertex. And angle 1 and angle 2 share a common side. So, we can see that these two angles share the same vertex and a side. But do they not have common interior points? Well, we can see that angle 1 isn't inside of angle 2, and angle 2 isn't inside of angle 1. So we can definitely say, and we can make the conclusion, that these two angles are adjacent. Now let's go ahead and take a look at the example to the right. This is angle 1, and this is angle 2. Angle 1 and angle 2 share a common endpoint, which is right over here. That's the vertex. And these two angles share a common side as well. Now, is angle 1 inside of angle 2? Nope. Is angle 2 inside of angle 1? No. So we can conclude that these two angles are also adjacent. Now, what are some examples of non-adjacent angles? Here's some examples of non-adjacent angles. Angle 3 and angle ABC are non-adjacent angles. This is angle 3, and here is angle ABC. We can see that angle 3 and angle ABC share a common endpoint over here at B. That's the vertex. However, angle 3 and angle ABC don't share a common side. And that's because angle ABC does not have this side whatsoever. Only angle 3 does. But we can see that angle 3 is inside of angle ABC. And that's not okay, because remember, in order for two angles to be adjacent, they have to be on the same plane, they have to have a common vertex, they have to have a common side. but one should not be inside of the other. And that's what this means over here. No common interior point. So let's make a note. Angle 3 is inside of angle ABC. So we can go ahead and conclude that these two angles are not adjacent. Not adjacent. Now let's take a look at the example to the right. Angle 3 and angle ABC are not adjacent angles. This is angle 3, and this is angle ABC. These two angles do not share a common vertex. So we can safely conclude that these two angles are not adjacent. Now moving on, a linear pair is a pair of adjacent angles with non-common sides that are opposite rays, which means you're making a straight angle. Or line. And this is a great example of a linear pair, and linear pairs generally look like this. So we have angle 1, and this is angle 2. Angle 1 and angle 2 share a common vertex and a common side. So that means that these two angles are adjacent. Now, these two angles also make a straight angle or a line, as we can see over here. This is a ray, and this is a ray. And these two rays are opposite to each other. So therefore, we can say that this is a linear pair. Now over here, this is not an example of a linear pair, and that's because, well, this is angle ADB, and this is angle ADC. They don't form a straight line or a straight angle whatsoever. So we can safely say that this is not a linear pair. And here we're going to move on to vertical angles. Vertical angles are two non-adjacent angles formed by two intersecting lines. So to summarize what vertical angles are two straight lines that intersect each other that form an X, where the angles across from each other are congruent. So if you have two lines, two straight lines that intersect over here, then the angles across from each other are congruent. So here's angle 1, here's angle 2. Angle 1 and angle 2 are across from each other, so therefore they're congruent. And here's angle 3 and angle 4. They are across from each other, so therefore we can say that those two angles are congruent. Now, vertical angles are two non-adjacent angles formed by two intersecting lines. With vertical angles, they are always congruent. So, let me go ahead and summarize what vertical angles are. You must have two intersecting lines where the angles across from each other are congruent. The angles that are across from each other are vertical angles. And again, with vertical angles, they are congruent. So let's take a look at these examples. You have two straight lines that intersect at this particular point. You have four angles created: angle 1, angle 2, angle 3, and angle 4. We can see that angle 1 and angle 2 are across from each other, so therefore those two angles are congruent by vertical angles. So angle 1 is congruent to angle 2 by vertical angles. And then angle 3 and angle 4 are across from each other, so those two angles are congruent. So I'm going to use two arcs to indicate that those two angles are congruent. So angle 3 is congruent to angle 4 by vertical angles. Now I want to go ahead and be clear about my arcs here. if I were to put one arc instead of two for angle 3, then I would be saying that angle 1, angle 2, and angle 3 are congruent to each other, which is not true. We can see that angle 1 and angle 2, they have the same shape and they have the same size. So those two angles are congruent. But comparing 1 and 3, those two angles don't have the same shape nor the same size. So I can't put the same number of arcs to show that those are congruent. I have to differentiate them. We can see that, again, angle 3 and angle 4 are congruent to each other. So I have to use 2 arcs instead of 1 to show that those two angles are congruent to each other. Now here's a non-example of vertical angles. We have angle AEB and angle DEC. Well, we don't have two straight lines here, so we can't say that these two angles are congruent by vertical angles. We don't have straight lines involved. So we can go ahead and just say that this is not an example of vertical angle. Okay, next. Lines, segments, or rays that form right angles are perpendicular. And we use this upside down T to indicate perpendicular, which can be indicated in a figure with a square. Perpendicular lines form right angles. And when perpendicular lines form right angles, that means 90 degrees. So when two lines intersect at a 90-degree angle, they are perpendicular to each other. Okay? So let's go ahead and answer these 4 questions here. So here we go. Number 1, name 2 obtuse vertical angles. We're dealing with vertical angles, and these angles must be obtuse. So remember from the previous notes, obtuse means you have an angle where it's greater than 90 degrees but less than 180. So looking at the picture to the right here, I can see 2 straight segments that form an X, and these 2 angles here are congruent to each other by vertical angles. So I draw one arc here and one arc there to indicate that those 2 angles are congruent. We have angle BCG. So BCG, and also angle FCD. C is the vertex. So when I'm writing my angles, C must be the middle letter. So let's write angle BCG. So I have my 3 points to write my angle here. And C is the vertex, so C has to be the middle letter. And angle FCD. So again, I have my 3 points. C is the vertex, so C must be written in the middle. Okay, so I'm telling the reader here that these 2 angles are vertical angles, and those vertical angles are obtuse. All right, I'm going to go ahead and show you another example. How about these 2 straight segments that form an X, and looking at this angle and this angle here, those 2 angles are vertical, specifically this and this. So F is the vertex, so F must be written in the middle when you're writing your angle. So we have angle GFH. Use a different color here. And angle GFH and angle EFB. And there you go. I got 2 examples for you for number 1. Number 2, name a linear pair with vertex B. So if I'm looking at the picture again, this is where B is. B is right here. That's our vertex. And we're dealing with linear pair. And a linear pair looks like this. So if I have that straight line, which a linear pair has, and some sort of ray or segment, which is right here, that's the one I'm talking about, well, we can see that this is a linear pair, And those two angles add up to 180 degrees. Okay, so what two angles create that linear pair? Well, that would be angle G, B. B is the vertex, so it has to be right in the middle. C. So angle G, B, C. And angle A, B, C. So angle GBC and angle ABC create that linear pair. Number 3, name an angle adjacent to angle GCF. GCF. And what does adjacent mean again? Well, adjacent means adjacent angles are two angles that lie in the same plane and have a common vertex and a common side but no common interior points. All right, well, C is the middle letter. That's the vertex. That's the vertex. So I'm going to go ahead and just draw a blue dot at C to remind ourselves that that's our vertex there. Okay, so if this is the vertex and we're trying to find an angle that's adjacent to this angle here, well, this and this are our sides. So if I'm looking at this angle here, so angle BCG, angle BCG, well, what can you tell me here? Well, angle BCG share the same vertex as angle GCF, right? They share that vertex C, and they share this particular side, which are the two things that you need to be adjacent. So angle BCG is a great example, and I can also say something about this. Angle DCF. Angle DCF is adjacent to angle GCF. Again, angle GCF is right here. GCF. And the reason why I chose angle DCF is because they share the same vertex, and this is also a side. They share that same side. Okay? So angle DCF is adjacent to angle GCF. Number 4, name a segment perpendicular to angle, name a segment perpendicular to segment AE. Okay, where is segment AE? Segment AE is right here. And that one segment that's perpendicular to segment AE would be segment GD. I'm choosing segment GD because you can see that these two segments intersect each other at a 90-degree angle, that square that we talked about at the beginning. Perpendicular can be indicated in the figure with a square, right? So segment GD intersects segment AE at a 90-degree angle. And yes, I can assume it's 90 degrees because it's stated on the picture, or it could be stated right at the beginning somewhere in the problem itself, right? I can assume that those two segments intersect each other at a 90-degree angle. If this square is not there and it looks like this, you cannot say that those two segments are perpendicular unless there is a square or the problem itself says, hey, these two segments are 90 degrees right from the beginning, and you can assume so, okay? So again, if you do not see that mark, if you do not see that 90-degree angle or that square on the picture, or it doesn't say in the problem itself, you cannot assume that those two segments are perpendicular, okay? So please make sure that you keep that in mind. I would write that on your piece of paper if you have to. All right, so that would be number 1 to 4 for this section of the notes. Complementary angles are two angles with measures that have a sum of 90 degrees. Again, you have to have two angles that add up to 90 degrees. That's what sum means. It means add in mathematics. So here are some examples. Angle 1 and angle 2 are complementary. That means that this angle plus this angle add up to 90 degrees. So whatever the measure of angle 1 is, so measure angle 1 plus the measure of angle 2, whatever that is equal to 90 degrees. And we indicate with that square to show that these two angles form that 90-degree angle that we know and love. We use that square, okay? And then here we have this pair here. We have angle A and angle B. Well, the measure of angle A is 65 degrees and the measure of angle B is equal to 25 degrees. If these two angles are being added together, well, they form a complementary angle, okay? So if I add up these two angles here, this will create that 90-degree angle, okay? So this angle plus this angle will make these two angles complementary to each other. All right, here we go. Supplementary angles are two angles with measures that have a sum. Again, sum means add. A sum of 180. Examples, angle 3 and angle 4 are supplementary. So angle 3 and angle 4, they are supplementary, so they add up to 180 degrees. And this, by the way, is an example of a linear pair. So the measure of angle 3 plus the measure of angle 4 equals 180 degrees. And then if I'm looking at these two angles here, angle P and angle Q are supplementary. And the measure of angle P is 120 degrees, and the measure of angle Q is 60 degrees. So if I add these two angles, which are not stuck to each other, but if I add these two angles up, well, what is that going to give me? It's going to give me 180 degrees. So we say that angle P is supplementary to angle Q. Okay, so let's go ahead and flip to the next page. Some pairs of angles are special because of the relationship between their angle measures. Vertical angles are congruent. And we've been talking about vertical angles a lot throughout the notes today. So remember, with vertical angles, you need to have two straight lines. Two straight lines that intersect at a point where it forms this beautiful looking X, as you can see. We have four angles involved. We have this angle, this angle, this angle, and that angle there. Okay? So the angles across from each other are congruent. Angle A, B, C is across from angle D, B, E. So those two angles are congruent, and we use these arcs to indicate congruency. I use one arc here, and I use one arc there to show that those two angles are congruent. Okay? And then we have angle A, B, D, which is across from angle C, B, E. Those two angles are congruent to each other, and we use two arcs instead of one to indicate congruency. So I have 1, 2, 1, 2. Okay? And the reason why I'm using two arcs instead of one is because I want to show that these two angles are congruent. Specifically, these two angles are congruent. If I used one arc here instead of two, I would be saying that this angle, angle ABD, is congruent to ABC and to angle DBE, which is not true. So if we look, obviously this angle is not congruent to this angle, and it's not congruent to that angle. This angle is a lot wider than this angle here. Okay, so I cannot use one arc for this angle, if that makes sense. So I would make a note, and I'm going to make a note right over here and say that the number of arcs used for one angle must match the number of arcs for another angle. And yes, I'm quite aware that this note is pretty long, but I really want you to understand that, okay, if I'm looking at these two angles in particular, those two angles are congruent, and I want to show the reader, okay, those two angles are congruent by using the number of arcs. We have one arc here and one arc there, again, to indicate congruency. All right, so just please make sure you understand what's going on with that one. Let's go ahead and take a look at this over here. The angles in a linear pair are supplementary. Now remember, with linear pair, looks something like that. We have those two angles that create that linear pair, and linear pair are supplementary, or sorry, the angles in a linear pair are supplementary. We have angle 1 and angle 2 that will create that linear pair, and we say that the measure of angle 1 plus the measure of angle 2, those two angles add up to 180 degrees. Again, those two angles are supplementary, okay? So I need you to understand these two things because they will be relevant, they'll be prevalent in semester 1 of geometry. So please make sure that you understand and know what vertical angles are and what a linear pair does. All right. Okay, so number 5 says find the measures of two supplementary angles if the difference in the measure of the two angles is 18. So I'm going to go ahead and highlight some key words here. I have supplementary and difference. Now, again, with supplementary, you have to have two angles, and those two angles must add up to 180 degrees, right? And with difference just means subtract in mathematics. Subtract in mathematics. All right, so again, find the measure of two supplementary angles if the difference in the measure of the two angles is 18. So I'm dealing with two angles here. I'm going to draw those two angles. I have the first angle, in which I will call angle 1. And I have the second angle over here, in which I will call angle 2. I don't know what the measure of angle 1 and 2 are. Why? Because it doesn't specify anywhere in the problem what measure angle 1 and measure angle 2 are, right? So what I have to do here is make a play. I actually have to call measure angle 1 something. But again, I don't have a specific number, so I have to resort to using the unknown, if that makes sense. I have to use something called x. Okay, so I'm going to call angle 1 x. So the measure of angle 1 is x. That's going to be our unknown, right? So what's the measure of angle 2? Well, let's read this again. Find the measure of the two supplementary angles if the difference in the measure of the two angles is 18. What that means is if I'm looking at this angle over here, it's this angle minus 18. In other words, it's x minus 18. Okay, so the measure of angle 2 is x minus 18. All right, so I have my two angles here. I have the measure of angle 1 and the measure of angle 2. Okay, so measure of angle 1 plus the measure of angle 2, and we can assume that those two angles are supplementary. Why? Because it's stated right here, so I can say equals 180. The measure of angle 1 is x, and the measure of angle 2 is x minus 18. So I say x plus x minus 18. I'm going to put parentheses around that. Why not? If this was subtraction, I need to use the distributive property, right? If this here was subtraction, I would have to use the distributive property, but it's a plus sign, so really it doesn't change anything in terms of the setup here. So I can go ahead and remove the parentheses now, because if I use the distributive property, it would just be x minus 18, right? X plus x minus 18 equals 180 degrees. All right, so now I have x plus x. I can go ahead and combine the like terms here. Well, how many x's do I have? Well, I have 2 x's. So x plus x is 2x minus 18 equals 180. And then I'm going to go ahead and add both sides by 18. So I have 2x equals 180 plus 18. That's 198. And then I'm going to divide both sides by 2 here. And I get x equals 99. So if x is 99, what's the measure of angle 1? Well, the measure of angle 1 is currently x, and x is 99, so it's 99. Measure of angle 1 is 99. And then the measure of angle 2 is just 99 minus 18. And 99 minus 18 is 81, okay? So let me go ahead and see. 99 minus 81, will that give me 18? Because it says right here, if the difference in the measure of the two angles is 18. So if I subtract 99 and 81, would that give me 18? Yes, it will. And that's how you check your answer. Okay, number 6, find the measures of two complementary angles if the measure of the larger angle is 12 more than twice the measure of the smaller angle. All right, so what are we dealing with here? I have two complementary angles. That means that those two angles add up to 90 degrees. Okay, so I have two angles here. I'm going to go ahead and say, or not really say, I'm going to draw one angle, and I'm going to draw the other angle. All right, so we have a smaller angle, which is this, and then we have the larger angle, which is that. The measure of the larger angle is 12 more than twice the measure of the smaller angle. Y'all, do we know how long the smaller angle is? Well, we don't. We don't know how long the smaller angle is, which I will call, again, x. All right? And the larger angle is 12 more than twice the measure of the smaller angle. So that means I'm going to represent that angle as 12 plus 2x. Okay? That means just when you see the words more than, that means you're just adding. You're adding more. All right? So I have those two angles. So I have x plus 12 plus 2x, right? So I have that smaller angle plus the larger angle. And those two angles equal to 90 degrees. And I'm going to go ahead and combine the like terms here. I have x plus 2x, which is 3x, plus 12, which is equal to 90 degrees. And I'm just basically solving for x at this point. So I'm going to subtract both sides by 12 here. And I get 3x equals 90 minus 12, which is 78. Then I'm going to divide both sides by 3 if I have some room here. All right, here we go. I got x equals 26. So if x is 26, that means the smaller angle is 26. All right, so I'm going to write that down. Smaller angle is equal to 26. And then this means that the larger angle is 12 plus 2 times 26, which is 12 plus 52, and that's going to give me 64. Okay, so the larger angle is 64 degrees. Number 7 says find the value of x and the measure of angle 1. Okay, so what am I dealing with here? Well, I have two straight lines that intersect each other. That means that the angles across from each other are congruent. This angle and this angle are across from each other, so I'm going to go ahead and draw one arc here and one arc there to indicate congruency. And I can say the same for these two angles as well. We have this angle and this angle. Those two angles are across from each other, therefore those two angles are congruent. So I'm going to use two arcs instead of one to indicate congruency. All right, so number 7 says find the value of x. Well, I don't have an equation to work with here, so I need to figure out what that equation is. Well, I know that we have 3x plus 50, that's an expression, and 6x minus 40. And again, these two angles are congruent in the world of geometry, but in the world of algebra, the measure of these two angles are equal to each other, right? So all I need to do is I set these two expressions here equal to each other. I have 3x plus 50, which is equal to 6x minus 40, and my goal here is to solve for x, so I need to get x on one side and the answer on the other side. All right, so I got to subtract both sides by 3x, and I'm going to add both sides by 40. And what do I get? I get 90 equals 3x. Then I'm going to divide both sides by 3. I'm going to use a different color to divide here. So divide this side by 3 and that side by 3. 90 divided by 3 is just 30. And then 3x divided by 3 is just x. So x is 30. That's the first part. So I can go ahead and box that in. So I found the first part. Now I got to figure out the second part here. What is the measure of angle 1? In other words, how long is angle 1? Now, where's angle 1? That's angle 1. Now, I just want to quickly preface this. This angle here is called angle 1. The one that you see right now does not mean it's 1 degree. Okay, it does not mean that the measure of this angle is 1 degree. It doesn't have that degree symbol right next to it, right? But what we need to do here is figure out the measure of angle 1. I don't know what the measure of angle 1 is. That's what I'm trying to figure out here. So what do I need to do? I need to create an equation. Previously, we were able to say 3x plus 50 is equal to 6x minus 40 because these two angles here are congruent by vertical angles. Well, these two angles are congruent by vertical angles, but we don't have an expression here or there, right? So we can't use vertical angles. We can't use vertical angles here. So what do we need to resort to? Well, we need to resort to linear pair because that's something that we talked about on today's notes, right? So what's linear pair again? The angles in a linear pair are supplementary. The measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. So going back, I need to find that linear pair. Okay, so where's that linear pair? Let me use my highlighter. Okay, we need to have a straight line and some sort of ray or segment. And there you have it. We have that linear pair, right? So this is my linear pair, and we have those two angles that form a linear pair. Okay, we have this angle, and we have that angle. And those two angles, again, form a linear pair, right? So we got 3x plus 50 and angle 1, or I should say measure of angle 1, right? So when I'm saying, oh, how long is angle 1, I mean measure of angle 1, which I'll write m angle 1. Okay? So, again, these two angles here add up to 180 degrees. And also, I think it's time for us to plug in, 30 into this x right there, right? Because we know that x is equal to 30. I'm going to replace x with 30 here. So 3 times 30 plus 50. Well, 3 times 30 is 90, right? Plus 50. And that's going to give me 140. So I can go ahead and create my equation now. It's one angle plus another angle equals 180. So 140 plus the measure of angle 1 equals 180. And my goal here is to solve for the measure of angle 1. And we're going to treat it like how we're solving for x. So treat it like x. So you're solving for the measure of angle 1. You want to get measure angle 1 by itself. So what do I have to do? Well, to get measure angle 1 by itself, I got to get rid of this 140, right? So I need to subtract both sides by 140. And then I get measure angle 1, which is what I want alone on one side of the equation, which is equal to 180 minus 140, which is just 40 degrees. All right? So how long is this angle here? Well, the measure of angle 1 is 40 degrees. So it's 40 degrees, right? So I have 140 plus 40, and they should equal to 180 degrees. Number 8 says find x and y so that line PR and line SQ are perpendicular. Okay, so line PR is right there, and line SQ is right there. Line PR and line SQ are perpendicular, meaning that they intersect at a 90-degree angle. So what I'm going to go ahead and do is I'm going to draw my squares to show 90-degree angles. So I'm going to draw a square here, and a square there, a square here, and a square there. Okay, so it says find x and y. So what do I have to do? Well, I see a y here, and I see two x's here. 4y minus 2 is this angle. But if we look really, really closely, that angle that I'm showing is 90 degrees, right? So 4y minus 2 is 90 degrees. So that's my setup right there, because I know that this angle is 4y minus 2, and it's also 90 degrees. So 4y minus 2 is 90 degrees. Is means equal in mathematics, so I can go ahead and create my equation for y. So I'm going to create my equation for y. So I'm going to do 4y minus 2 equals 90. And then I'm going to add both sides by 2 here. So I have 4y equals 92. And then I'm going to divide both sides by 4. So y equals 23. And that's all it's asking me to do for y. I don't need to plug anything in. All right? So now what do I have to do? I need to figure out what x is equal to, right? So, y'all, we have this being 2x, that angle is 2x, and this angle here is 5x plus 6. But if we add up these two angles, well, these two angles are complementary to each other. They add up to 90 degrees, right? So to create my equation for x, all I have to do is I take 2x plus 5x plus 6, right? I have those two angles, and I equal that to 90 degrees. So then I'm going to combine the like terms. I have 2x plus 5x, which is 7x, plus 6 equals 90. Then I'm going to subtract both sides by 6 here. So 7x equals 90 minus 6 is 84. So then I'm going to divide both sides by 7. X is equal to 12. And there you have it. We have x equals 12, y equals 23. That's all I need to figure out here, because it's saying to find x and y. Now, cool, let's look at the second to last problem. The measures of two complementary angles are 10x minus 5 and 5x plus 20. Find the measures of the angles here. Key word is complementary. That means you're going to add these two angles and equal that to 90 degrees. So I have 10x minus 5 plus 5x plus 20 equals 90. And then I'm going to go ahead and combine like terms here. Got 10x plus 5x, which is 15x. And then I have negative 5 plus 20. So negative 5 plus 20, that is just positive 15. Again, you're going to equal that to 90 here. Subtract both sides by 15. So 15x equals, well, what's 90 minus 15? That's 75. So now we got to divide both sides by 15 here, right? So I'm going to divide both sides by 15. X is equal to 5. So if x is equal to 5, am I done? Nope, I got to figure out the measure of the two angles here. So this is angle 1 and this is angle 2. So the measure of angle 1 is currently 10x minus 5. So I'm going to replace x with 5. So 10 times 5 minus 5. 10 times 5 is 50. 50 minus 5 is just 45. Right? So it's 45 degrees. And then the measure of angle 2 is 5x plus 20. 5x plus 20. And then I equal that to 5 times 5 plus 20. So 5 times 5 is 25. 25 plus 20 is 45 degrees. And those are your two answers. Last problem. Now make the angles in problem 9 a linear pair. Find the measures of the angles. So linear pair, you're taking those two angles and you're going to set it equal to 180 degrees. So all I need to do is I'm going to do 10x minus 5 plus 5x plus 20. And you're going to equal that to 180 degrees, right? Those two angles, angle 1, angle 2, they should add up to 180. So, all right, well, if I combine the like terms, I would get 15x plus 15, right? So I'm going to write 15x plus 15. I'm not going to show the steps to combining like terms again because we already did that, right? So 15x plus 15 equals 180. Then I need to subtract both sides by 15. So 15x equals, well, what's 180 minus 15? 165. So now I'm going to divide both sides by 15. X is equal to 11. And if x is equal to 11, well, I'm going to call this measure angle 1 and measure angle 2 again. So measure angle 1 is 10x minus 5. And I'm going to replace x with 11. So 10 times 11 minus 5, that is 105 degrees. So 105 degrees. And then the measure of angle 2 is 5x plus 20. So 5 times 11 plus 20. 5 times 11 is 55 plus 20. That's 75 degrees. So I have 105 degrees and 75 degrees. Those are my two answers for number 10.